This is going to be my next lever launcher experiment. So it's still the same wooden stick with the rubber band on this side. And this time I'm going to let the pendulum launch. The pendulum will be launched. So the pendulum is the carbon rod with the one mass at the bottom. This is the timer. At the bottom of the one mass we have a little flag that will go through the timer. I have these little pieces of cardboard to hold the carbon rod or the pendulum in place. So now its position is locked. It's a little gap, as you can see. And at the bottom, so here is the flag. And on the other side we have the lower end of the carbon rod. And that fits into this little gap. And what I'm going to do is just simply pull it backwards. So this is the one mass at two distances from the fulcrum. Pull it backwards and launch. And we're going to be able to see what the timing will be. And then the same with the two mass launched from one distance of the fulcrum. So that might be interesting. Of course, I also have to mention Ian Gostin, who has done many of these tests with the pendulum being launched. But since I have the timer, I should have more accurate results. Alright, let me show you once again the distances, because otherwise you will say that I'm not providing all the information. So the total length of the lever is 50 centimeters, and you can see that the middle, the fulcrum is at 25 centimeters. Now the distance from the fulcrum to the two distance over here is 23.8. Divided by 2 is 11.9. So for the one distance, as you can see, 11.9. Precisely at 11.9. So, which means that this one is exactly at twice the distance from the fulcrum, and this is exactly in between. So the distances are correct. And also, once again, let me show you the masses of these objects, of the pendulum as a whole. 87.60. And now the one mass, 44. So the other one was 87.60. So twice the mass should be 88. So it's almost perfectly twice the mass. Right, let's do a couple of tests. Over here I have the timer, and yeah, I'm just gonna do a launch test. First gonna put it over here. Right, that gave us 52. Damn it. All right, second trial. $52 again. Third trial. Third trial. 52 again. $50. One more. Hold on. Right, once more. 51. I think we have really consistent results. 49. 48. Hold on. It's getting twisted a little bit. 50. So I think it's pretty clear that on average we have 50. Okay, now we have the two mass at the one distance from the fulcrum. Put on the timer. Okay. 74. 74 again. 72. 74 again. 73. Pretty consistent results. 75. Okay, so on average we had, for the one mass we mostly had 52 for the timings, and for the two mass we mostly had 74. So let's do the calculations. 74 divided by 52 equals 1.42. So once again, this famous number 1.42 or 1.41 pops up, which proves that once again the one mass launched at two distances from the fulcrum goes 1.41, or in my case 1.42 times faster than the two mass launched at one distance from the fulcrum. Coincidentally, right? What a coincidence. What a coincidence once again for the 100th time that this number pops up. Not 2 times, but the square root of 2, 1.41.